Dear students, so today we shall have a discussion in continuation with the construction of CNC machines. Basically, we are concentrating on the importance of different types of bearings being used on CNC machine tools. So before we proceed with the today's session, we need to understand what we have discussed in the previous session. So in the previous session, we have discussed in length in connection with the torque transmission elements. So in that, the spindle and spindle bearings play a major role as far as the accuracy of production of the job is concerned in case of a CNC machines. If the spindles and the spindle bearings are not designed in a proper way, then there will be a cause of eccentricity of the rotation of the spindle if the bearings are not properly mounted, or if the bearings are not properly maintained. Then that every chance is there that the workpiece may not be able to be rotated, means along with the central axis. Eccentrically it may be subjected for the rotations, by means of which it is not possible to achieve the accuracy of machining. So that can be avoided if a proper type of bearings are being used in case of CNC machines. So we need to understand few important types of bearings which are commonly used in case of CNC machine tools. So in that we shall have a discussion about the three important types of bearings, that is hydrodynamic bearings, hydrostatic bearings, and anti-friction bearings. So in that anti-friction bearings you have already studied in the previous courses, okay, in detail, but again it is just like a revision only. So let us understand again what is the major role of the spindles which are used in case of a CNC machine tools. Basically the spindles are used for the purpose of either holding the workpiece or the tool. If you take an example of a simple lathe machine or even a CNC turning center, okay, the workpiece is held in a spindle, okay, and the cutting tools are held in the tool turret, okay. So in both the cases we require to have the spindles. Otherwise, whatever, for example, if you take the rotation of the workpiece, it is carried out by making the workpiece to be mounted over it, and the accuracy of rotation of the spindles play a major role as far as the workpiece rotation is concerned. Similarly, the cutting tools which are mounted on the tool turret are also indexed. So that means even the tool turret head is also mounted on a spindle, and the bearings are responsible for supporting the spindles. That is very, very important. So that is why always the spindles are subjected to few important deflections. They are subjected to torsional deflections because of accuracy of rotations, high speed of rotations, and radial deflections, and also thrust forces during the power transmission, okay. Because whenever we are going to use the spindles on which the workpieces are being, or the tools being mounted over it, okay, whatever the rotation of the spindles is there, during the rotation also they are, especially the workpiece is subjected for thrust forces due to the machining operations. So in that condition the spindles should be designed in such a way that they should be able to sustain all these types of deflections. So that can be achieved correctly if at all the spindle bearings are properly mounted on a CNC machine tools. Stiffness of the spindles is improved to minimize the torsional strain. So whatever the spindles, the properties of the materials of the spindles, okay, play a major role as far as its the performance is concerned. The rotational accuracy depends on the quality and design of the bearing. How best and what type of bearing being adopted, that decides the rotational accuracy of the spindles, and in turn that decides the rotational accuracy of the workpiece or the cutting tool being held on the spindles in case of a CNC machines. So to have a discussion in connection with the definition of a bearing. So the very general definition of bearing says that it is a supporting device for the spindles. That is the main objective of the spindle bearings. CNC machine tools carry spindles on which either the workpiece or a tool is mounted. The function of the bearing is to hold firmly and rigidly the spindle both radially and axially to achieve excellent running accuracy. The main function of the bearing is in such a way that it should be able to sustain the radial forces, it should be able to sustain the axial forces as the spindle is made to rotate. The spindle bearing act as a support for the spindles which are rotated at higher speeds of more than 6000 rpm. This is very important. So whatever the rotational speed is there, the rotational speed is very high speed in case of a CNC machines. So the accuracy of design of the bearings play a major role as far as the performance of the machining is concerned. So now we need to go deeper into the section, that is the types of bearings which are commonly used in case of CNC machine tools. So in CNC machine tools there are three important types. The first one is called as hydrodynamic bearings. So it is a journal bearing with a thin film of oil. So we know very well that the spindle is nothing but a shaft, okay, which is made to rotate in a supporting device called as a bearing. Okay, so whatever the annular space is there between the spindle and the supporting element, that is provided with the thin film of oil. And in case of hydrostatic bearings, journal bearings with thick film of oil. If at all the viscosity of the oil is more and if the thickness of the oil is more in between the spindle and the supporting element, then we call it as a hydrostatic bearings. And anti-friction bearings, point or line contact bearings, which are commonly used in case of machines. So now we need to understand deeper into the section here, as you are going to see clearly. So there are a few important elements, the commonly used, which you are going to see there. The first one that you are going to see here is, so this is called as the spindle, and this is called as the annular space, and this is called as a supporting device. And this supporting device is provided with two ports there. So you are going to see the oil entering, okay, and the oil exhaust. So there are two ports here which you are going to see here very clearly. So the oil enters here and the oil goes outside. Again, alternately they are doing. Observe very carefully here. The oil enters, the oil goes, again oil is entering, oil is like this. Okay. So now what is going to happen, whenever the spindle are made to rotate at higher speeds, the oil will enter and again it comes outside. So here a thin film of oil is maintained between the spindle and the bearing. And whatever the pressure of the oil is there, that pressure of the oil is created purely by the rotation of the spindle only. Means the rotation of the spindle decides, okay, the pressure of the oil through which it is made to go outside and again it is made to come inside. Okay, the pressure of the oil is created within the bearing by the rotation of the spindle. The oil in contact with the spindle is carried into the wedge-shaped cavities as the spindle rotates. So these are called as wedge-shaped cavities. These are called as wedge-shaped cavities, okay, through which it goes and again it comes inside there. The oil pressure is increased as the oil is forced through the small clearances between the bearing and the spindle. As you are going to see here, whatever the space is there, in this space it will go outside and again it will come inside like this. So that itself is responsible for what the oil is forced due to the clearances, means gap. A definite clearance of 50 micrometer to 200 micrometer is provided for the oil film to be maintained between the spindle and the bearing. So as you are going to see, this is called as the clearance. That is the gap which you are going to see here, that itself is called as the clearance. So this space which you are going to see, because this is the spindle and this is a stationary element, so in between that whatever the space is there, so that space distance is approximately 50 micrometer to 200 micrometer in order to maintain the thin film of oil continuously when the spindle is made to rotate. This clearance causes the spindle center to shift from its position, leads to variation in the applied force. It's a very common thing that there is every chance due to rotation that the axis may not be maintained when the spindle is made to rotate at a higher speed, and that is why such bearings are used for low load carrying capacities where frequent starting and stopping of the spindle is not required. So only when, so that means it is very clear, hydrodynamic bearings are used for low loads, not for heavy forces or heavy machining operations. So these can be preferred for low machining operations, CNC means on a CNC machines where the machining forces are less and where the frequent starting means continuously starting and again stopping is not there. In that conditions, hydrodynamic bearings are more applicable. So that is why these are preferred for the grinding machines, because what is the main objective of the grinding machines? In case of a CNC grinding machine, what happens? There is no question of stopping of the machine. So once the tool is set, what happens there? The grinding, till the grinding process is completed, we are not going to stop the machine itself. So that is why it is very useful, especially in case of a grinding machines. So now let us understand what are the advantages of the grinding machines. So they are very simple in construction, as you are going to see very clearly there. Good damping properties means the vibration absorption whenever the spindles are made to rotate within the bearing, the absorption capacity is more or a good, and good running accuracy. All these are few important advantages. Okay, that means good running accuracy means what? Irrespective of the loads, though they are preferred for low load capacities, the axis is maintained properly. So that is the main advantage of the hydrodynamic bearings. Now we need to understand what is the hydrostatic bearings. As far as the working principle is there, it is same. The only difference is that in case of hydrodynamic bearing, the oil is forced and the oil is maintained automatically as the spindle is made to rotate between the clearance. Okay, but in case of the hydrostatic bearings, which you are going to see on the screen, we require to have a separate pump. A pump is used, okay, and that is responsible for sending the oil in the annular space between the spindle and the supporting device called as a bearing. So that is why it is possible to go for a thick film of oil, and the load carrying capacity is definitely more, because we are providing an extra support for the bearing by the provision of a pump, because the main function of the pump, which is external to the bearing, okay, so it is going to be operated continuously, so that it is possible to achieve or to maintain a certain thickness of the oil between the spindle and the bearing, and these bearings are more suitable for what? Higher load carrying capacities compared to the hydrodynamic bearings. The spindle is supported by a relatively thick film of oil supplied under pressure. So now what we are going to do here, we are going to supply the oil pressure. So that is why, as we are going to see in this page, there is a thick oil is maintained continuously, okay, and when the thick film of oil is maintained, it is possible to see that the spindles can be subjected for higher loads capacities can be possibilities there. The oil is pressurized by an external pump. When the spindle rotates, the oil exits from the exit port. So as the spindle is made to rotate, it will go out of this. Load carrying capacity is independent of the rotational speed, means it is not depending on the speed. So these are highly expensive, definitely compared to the hydrodynamic bearings. These are more expensive type. So now what are the advantages? Let us see here. Just I have told that this is a very simple sketch of a hydrostatic bearing. So where you are going to see that a pump is used, and this is the oil inlet, and this is the bearing, this is the spindle shaft. So the thickness of the oil is maintained as per the requirement with the help of an external pump here, which you are going to see. The external pump will continuously pump in the annular space between the spindle and the bearing or a supporting device. This is a simple sketch of understanding of the hydrostatic bearing. So let us understand what are the advantages. It's having a high damping properties, means it can take heavy loads, heavy cutting forces. So whenever the machining operation is carried out, in case of a CNC machines, it is possible for such bearings to take higher loads compared to the hydrodynamic bearings. High running accuracy is there and high wear resistance is there. Whatever the wear resistance, the capacity is more there. Definitely due to that there is a high wear resistance, because we have provided the pump itself for the continuous flow of a thick film of oil between the spindle and the bearing. So that is very, very important. Now, apart from these bearings, so which are the commonly used and which you have already studied in the previous semesters in connection with the anti-friction bearings. So in case of a very general concept of the anti-friction bearings is that these bearings require a proper type of a lubrication, and the most important thing is we require to use the rolling elements, and those rolling elements are called as the balls or the rollers. So these balls are or the rollers are held between the two rings. So those rings we are going to call as inner race and outer race, or sometimes we also call it as a cage, in which these balls or rollers are held, and as the shaft rotates and due to the entire whatever the load is there, it is directly coming on the balls or the rollers. So in case of a balls it is a point contact, and in case of the rollers it is called as a line contact. So in case of anti-friction bearings, there are two important types of bearings which are commonly used. One is called as the ball bearing and second one is called as a roller bearing. Again, in that there are various types like deep groove ball bearing. Okay, and in case of roller bearings you can have cylindrical roller, tapered roller, etc. So that depends, again depending upon the specific applications of machining, load carrying capacities or the speed requirements, etc. So we need to understand what are the basic types of bearings which are commonly used, with the brief understanding of the working of the same. An anti-friction bearing is a bearing that contains moving elements to provide a low friction support surface for rotating or sliding surfaces. So we require to provide a low friction here. Whatever the friction is there, that we require to reduce. So that is reduced with the help of the rolling elements known as the balls or the rollers. The anti-friction bearings are commonly made with hardened rolling elements. So they are called as the balls and rollers and races altogether, suitable for high speeds and high loads due to their low friction or negligible starting friction. So that definitely you can see there, whatever the capacity of the anti-friction is there, it is more better than hydrodynamic or hydrostatic bearings because of few important advantages which you are going to see there. They can be made to run at high speeds, and high load carrying capacity is also there, provided if a proper care is taken to see that the lubrication is carried out correctly. That is very, very important. And let us understand, as you are going to see here clearly, the cross section, you are going to see the shaft being rotated, and these are called as the rollers, and this is called as the ball, and this is called as the outer race, and this is called as a inner race. So this is how, as you are going to see clearly, this is how the structure of your anti-friction bearings are there for better understanding of the concepts. Now let us understand. So as you are going to see very clearly, a simple sketch is there with some sections which have been shown as the ball bearings. So in ball bearings, spherical balls are used as rolling elements. The balls are spherical type. Okay, so those balls are being used as the rolling elements. Basically they are allowed to roll within the races, inner and outer race. The contact between the inner race and the ball or the outer race is a point contact. There is a point contact between the inner and outer race. Yes, there is a point contact with these two races. So it is a higher pair, which already studied in the subject of mechanics of machines. So now we need to understand, of course, common types of ball bearings. Just it's a cut section, as you are going to see very clearly here. So here the cut section is shown now for better understanding. Now you are going to see clearly here, this is an inner ring, okay, or inner race, outer ring, and this is called as a ball which is held, and this is called as a separator. This is called as a separator. So in that there is a holding of the ball. In this case the rollers can also be used, as you are going to see here. The same concept is there. There is no much difference in the concept. So we need to understand here that how we are going to apply it and use it. Okay, so this is a cylindrical roller, and this is again inner ring, and this is the outer ring which is there. In between that the rollers are being held and used for the specific purpose. Similarly here again tapered roller bearings are also used. So whatever the type of bearings which are there, so those are used depending upon the your type of machine, the capacity of the load to be carried by it, and at what speeds requirements of the spindles is there. So that decides, okay, the type of bearing that can be used in case of a CNC machines. Now if at all the ball bearings are replaced by the rollers, then we call it as a roller bearings. The roller bearings use the cylindrical rollers. They are of a cylindrical type. Okay, taper rollers or spherical rollers as the rolling elements. So these are the few important types, okay, the forms of rollers. So it can be of a cylindrical type, or it can be of a tapered type, okay, or it can be of a spherical type as the rolling elements. The contact between the two rays is line contact. This is very, very important. The whenever these rollers are being accommodated between the two races or rings, that is called as inner race and outer race, so there will be a line contact. Unlike ball bearings, in case of ball bearings it is a point, only a point contact is there, and whatever the load is there of the spindles is directly coming on the balls only or the rollers. So observe how the accuracy of rotation is maintained in case of the ball and roller bearings very clearly there. So here you are going to see there the outer race, inner race, okay, and how the balls are made to rotate along with that. In the left side you are going to see the ball bearing, and in the right side you are going to see the roller bearings, how they are made to carry out for the purpose of rotational speed, power transmission as a supporting device in case of a CNC machines, as you are going to see there. Now let us understand what are the applications of the roller bearings. Okay, industrial and automotive gearboxes and at different automobile, especially these bearings have excellent applications in case of automobile industries and in case of electric motors. So whenever I want to go for the design of an electric motors, I require, because there we are converting the electrical energy into mechanical energy. Okay, so that means we require to see that the torque or the power is maintained properly in case of electric motors. Okay, whatever the armature shafts are there, they have to be supported at the ends with the help of bearings only. Machine tool spindles, as you are going to see, this is a very common thing where the application is there. In all the types of machine tool spindles we require a support, so that is why there is an application of roller bearings. Small size centrifugal pumps, even in case of centrifugal pumps also, okay, on that support is given with the help of the bearings. And automobile front and rear axles. So these are just a few important applications. Other applications are also there. So these are just few important applications as enlisted, okay, for better understanding of the concept. So now what are the advantages of anti-friction bearings? So this is very, very important to be noticed here. Ability to resist the shock load. The most important advantage is, whatever the shock load means, because just I have told that the main function of the bearing is to sustain the axial and radial loads. That loads will directly come on the spindle and in turn to the bearings. Okay, so if at all the bearings are not designed with the proper type of material and not properly mounted, then all these problems will exist. There will be a vibration in the machining operation also. But apart from that, these bearings have got the capacity to absorb the shock loads, that is the sudden load. There will be a sudden, as per the machining operation, the machining force, the cutting force will go on changing continuously. Sometimes it is very low, sometimes it is very high, like that. So easy for mounting, the mounting is very easy of all these anti-friction bearings. Low starting and running friction except high speed, except the high speed, low starting and running friction. Okay, whatever the friction is there, that is very less. More accuracy in shaft alignment, definitely. Why the alignment is maintained? The alignment is properly maintained because as the entire force, the support for the spindle is given with the help of inner and outer rays, and in between that the balls or the rollers are mounted. So that is why what happens, the accuracy is maintained better compared to the hydrostatic and hydrodynamic bearings. Compact required less space, this is another advantage. It is a very compact one. Okay, and the space required is also very less, and the maintenance cost is also less, and no lubrication is required during the operation. This is very important. Okay, so these are some of the few important advantages of using the anti-friction bearings, and along with this I am also going to attach some of the important videos in connection with the applications of the different types of bearings which we have already discussed here, and you need to write in a separate notebook the answers for all these questions, like define a bearing, list the types of bearings, explain the principle of hydrodynamic bearings. So you need to draw the sketch of a hydrodynamic bearing and you have to explain how it works. Similarly, hydrostatic bearings, and explain the principle of anti-friction bearings. So these are the expected questions which are going to come in the examinations. So you require to study them along with the sketches. Okay, that is very important point. Okay, with this I am going to finish today's presentation, and along with this I am also going to attach some of the important videos. Just go through that for better understanding of the concepts.
And it will pump through the pipe, and our shaft will going upward by the external field of action. The oil will supply through this pipe and pump will pump the oil, and shaft will going into upward direction. So gap is maintained between bearing and journal. Now we can start our working. The shaft will rotate after making a lubricating oil film between the bearing and journal. This is the gap which is created by the external source, means by the pump, and lubricating oil is supplied by the pump through externally. So hydrostatic bearing and hydrodynamic bearing are different by this way. Hydrostatic bearing supply external oil, pressurized oil to the bearing, and hydrodynamic bearing creates by its own. So this was the working of hydrostatic bearing. Thank you. Today we will discuss about hydrodynamic bearing. We will discuss about the parts of the hydrodynamic bearing. We have a shaft or journal, and we have a bearing in which shaft is placed. The upper portion is bearing and inner portion is shaft or journal. Now see the side view of the drawing. This is shaft or journal and this is bearing, and in between these two there is a lubricating oil. Now see the animation of the hydrodynamic bearing, how shaft will rotate and create a lubricating film between shaft and bearing. There will be bearing and journal. The shaft will rotate and create a lubrication film between shaft and bearing. This film creates a smooth working of shaft. As we increase the speed of the shaft, this oil film will make between the shaft and bearing. This is the action of hydrodynamic bearing, and this is the film between shaft and bearing. This film is created by the rotating of the shaft. So this is a process of hydrodynamic bearing. Thank you.
Hi, John here. In this video we're going to be looking at also going to know what the two main categories of bearing are, what the main components of anti-friction bearings are, and how anti-friction bearings work. So let's start with the basics. There are two main categories of bearings, anti-friction bearings and plain bearings. Now we'll cover plain bearings in a different video. Let's focus on anti-friction bearings. Anti-friction bearings are also known as rolling contact bearings, rolling element bearings, and rolling bearings. All of these names refer to the same thing. These are just other names for an anti-friction bearing. In order to keep things clear, we're going to call them anti-friction bearings only. There are two main categories of anti-friction bearing, ball and roller. As the name implies, ball bearings use balls as rolling elements. Roller bearings use rollers as rolling elements. In order to understand the difference between the two main types of anti-friction bearing, we need to have a look at the construction of an anti-friction bearing. An anti-friction bearing consists of rolling elements, a separator, an inner ring, an outer ring, and sometimes a shield or a seal. You're now looking at a cross-section of a ball bearing. Let's take the bearing apart and look at each of its parts individually. This particular bearing uses balls as the rolling elements. A separator is used to evenly space the rolling elements apart. The separator is also known as the retainer or cage. Now that the rolling elements are evenly spaced apart, we can view the final two pieces, the inner ring and the outer ring. One of the reasons that learning about bearings is so confusing is because many of the components all have several names. An inner ring is also known as an inner race. On tapered bearings, it will also be known as a cone. The outer ring is also known as the outer race. On tapered bearings, it's also called the cup. The separator is also known as the retainer or cage. To recap, the balls form the rolling element of a ball bearing. For roller anti-friction bearings, the rolling elements may be cylindrical, barrel, tapered, or needle-shaped. The separator is used to evenly space the rolling elements apart. The separator is also known as a cage or retainer. The rolling elements are sandwiched between an inner ring and an outer ring, also known as an inner race and outer race, or for tapered bearings, a cone and a cup. Some bearings may be installed with a metal shield, which protects the bearing to some degree from foreign particle ingress, which may contaminate the lubricant inside the bearing. If the internals of the bearing must be completely sealed from the outside, then a seal will be used instead of a shield. Seals are usually manufactured from rubber or Teflon. Seals completely seal the internal parts of the bearing, which prevents foreign particle ingress and moisture ingress. Seal bearings are sealed for life. The lubricant housed within the sealed area is used to lubricate the bearing until the bearing no longer functions or is replaced. Typical lubricants for anti-friction bearings are grease and oil. Grease contains oil, although a thickening agent is added to make the lubricant adhere to the bearing's internal surfaces. Thickening agents are usually soap or non-soap based. When an anti-friction bearing has no shield and no seal, it is classed as an open bearing. Most anti-friction bearings utilize one stationary ring and one rotating ring. The rotating ring is usually the inner ring, which is connected to a shaft. The stationary ring is usually the outer ring. As the shaft rotates, the inner ring also rotates, as do the rolling elements. Notice that the movement of the shaft is not transferred to the stationary ring. So you've now learnt what the main two types of bearing are, anti-friction and plain bearings. You also know what the main two categories of anti-friction bearings are, ball and roller. We've discussed all of the main components of anti-friction bearings and how anti-friction bearings work. Please do be aware though that there are different variations of every kind of anti-friction bearing. Some anti-friction bearings do not use an inner ring. Some anti-friction bearings do not use a separator. If you'd like to learn why that is, then check out our anti-friction bearings course. In the course, we'll discuss ball anti-friction bearings, as well as cylindrical roller bearings, tapered roller bearings, needle roller bearings, and barrel roller bearings. The anti-friction bearings course is just one of many engineering courses, and if you're a student, you can access all of these engineering courses for only $19.99 a year. If you